Recording. All right, so we haven't covered any topics in the regular course, so nothing to practice on there, but we do have something that we're going to use a lot this semester, and most people just aren't the best at it. It's fractions. So I thought we'd do some review on some fractions today. 335, let's say this is review for not review, but for R1, R2 day. And we're going to look at fractions. So fractions represent part of a whole. I have something that's broken up into 4 pieces, and I have 3 of them filled. I could say that 3/4 of these blocks are filled, and 1/4 is empty. You'll notice if we add the fractions together, we should get the total. The whole thing is just, this is one big block broken up into 4 pieces. And so if I add them all up, it should add up to 1. And if I look at it as the tiny pieces, it looks like there's 4 pieces over 4. So what we're doing is each time the number on the bottom, the denominator, represents how many pieces the unit is broken up into. And the number on top, this, point at them each individually because I didn't give myself room earlier. This is called the numerator. And this is the number of pieces with the trait we're looking for. Or how many are selected. That is the official jargon, numerator, denominator. I hate writing that fucking word. I really do. They're too long to write. You will hear me call them top and bottom, because that's where they're located on the fraction. Right? Why call it some big long name? That's not even easy to spell. I can't tell you how many times I've spelled denominator as demoninator. Switch the M and the N so it says demon. I don't know why. Something else we could notice from this. They do add up to the whole number, so 1/4 plus 3/4 equals 4/4. And notice what's going on here. If I look at it, rewrite it down here so I can scribble on it without fucking up my notes. When adding fractions or subtracting, the bottom needs to be the same. So that's important. Notice 1A. The bottom needs to be the same, and if not, make them the same. And we'll do that on the next little bit. And it stays 4 across all of them. Now that 4. And now if I look at the numerators, notice I've got 1, 3, and 4. And if I just put that plus up here like that, 1 plus 3 equals 4. So when we're adding fractions, the bottom needs to be the same, and it stays the same. We only add the top. Or add and subtract. Multiplication will be different. If we do subtraction, I did 3/4 minus 1/4. The bottom is the same, so I'll still have the 4 on the bottom. The top will be 3 minus 1, which is 2. So I have 2/4. So this will lead us to step 3. C. Try to simplify or reduce the fraction if you can. And I'll do this on both the 4/4 and the 2/4. So on the 4/4, if you have a number that is on the top and the bottom, you can cross them off and replace them with 1s. It's important to know that they're replaced with 1s. Not everybody writes the 1 in, but if you don't write the 1 in and you just look at it, some people, I've had calculus 3 students thinking that it just goes to 0 because they didn't write the 1 in, and it doesn't. It goes to 1. So I now have 1 divided by 1 is just 1. So when the top and the bottom are the same, it's you get 1. When they're not the same, it's helpful to write them as do like a prime factorization. Write them as the numbers that multiply to make them. What 2 numbers multiply to make 4? 2 and 2, right? And so in this case, I've got a 2 on top and a 2 on bottom. I can only cancel out one of the ones on bottom to cancel the one on top. So now I'm left with 1 on top, and 1 times 2 on bottom is 2. So I've got 1/2. So 2/4 is the same as 1/2. These are called equivalent fractions. And these ideas are going to hold true even when we've got variables and letters in them and all sorts of shit in there. But still, when you're adding or subtracting, the bottom needs to stay the same, and we're only working with the top. So let me give you guys some examples, or maybe give you something to work on, try out. Let's do 5/8 minus 3/8. Let's have you do that. And then let's have you try, let's go 3/12 plus 7/12. Get a little bit to figure that out and we'll do it together. Should we? Hold up the cover. Oh, yeah, I read it. It's a good series. Wow, since I read it.
And then my was just read it in high school. It's talking book series I like, so kind of.
Oh, if you like fantasy series, I'll tell you all sorts of shit with fantasy series. That's my jam. As I told you guys on day one. All right, anybody still working on it? So I'm getting, let me make a little note, because I scan these. I'll put them up on our Canvas shell. So this will be page 2. So if I do the same thing that I did before, I'm going to keep the 8 on bottom and I'll have 5 minus 3 on top. And 5 minus 3 is 2. And 8 is 2 times 4. You could alternatively write 2 times 2 times 2 if you wanted to break it all the way down, but you don't have to. At this point, I see that 2's cancel. Get replaced with 1s, and I'm left with 1/4. So I hope you guys got that. What'd you guys get on the other one? 3/12 and 7/12. 5/6. Anyone else get 5/6? All right, that's what I'm gonna get too, I think. Let's check. I got 12 on bottom and 3 plus 7 is 10. So 10/12. You'll find it's helpful to maybe do the thing that has the least number of terms first. 10 is only 2 times 5. I only give a shit if 12 has a 2 or a 5 in it at this point. So if this was like 1,050 or some shit like that, I only care if a 2 or a 5 appears. You don't need to look for 3s or 7s or anything else. You're only looking for what's canceling on the other side. 12 is 4 times 3, and 4 is 2 times 2. So 2 times 2 times 3. I could have left that as 2 times 6. It's probably the better route to go if I wanted to keep it clear. And the 2 cancels, or there, leaving behind a 1, and we have 1 times 5 is 5 on top. 1 times 2 times 3 is 6 on bottom, so 5, 6. All right, so what do we do when they don't look alike? We're gonna make this go big. So let's see, let's say we wanna add together 3/4 and 5/6. I'm gonna do another one because a lot of people just tell you to multiply through by the other denominator, so that's shitty. Let's do something else. Let's add in 1/8. And I will do that. I'm pretty sure I'm doing this topic again. I'm like, not maybe Thursday in the main class, maybe. So one way is what we need to do when denominators are different, when bottoms are different. We need to find the LCD, least common denominator. I will show you a way that I came up with in the shower one day. It seems odd, but I had a student that just was not getting this several years ago. And I could not think of any other way to explain it to him, and I came up with this table method that I think is fucking phenomenal. And not only is it good for the least common denominator, it'll be good for greatest common factor and all sorts of things. What I'm gonna do is I'm going to write down what the four or the three denominators are. And I'm going to just start off and factor them one at a time. 4 is 2 times 2. Now, when I do the second line, if I have a number, a factor that appears in the top line, I'm going to write it below it. And if it doesn't appear in the line above it, I'm going to make a new column. So 6 is 2 times 3. I have a column for a 2. And I don't have a column for a 3, so I'm going to come over here and make a column for a 3. And 8 is 2 times 4, which is another 2. There's 3 2s here. And so I need a third column for another 2. The least common denominator, it's also called the lowest common multiple or least common multiple. The only reason they use denominator here is because it's part of the fraction. Is bring these each down and multiply them. 2, 2, 3, 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 6 is 24. So my denominator is going to be 24. Now, how does that help me figure out what to multiply each thing by? Get a second to make sure you're all caught up. Helps to use a different color if you have it for the next part. Because what we're going to do is I'm going to fill in the gaps that all these things are missing. So the 4 is missing a 3 times 2. Which means the 4 needs to get multiplied by 6. And if I multiply by a 6 on bottom, I want to multiply by a 6 on top. Because remember, the number over itself is 1. If I multiply by anything but 1, I'm going to change its value. If I multiply by 1, it stays the same value. So this is 1. I'm going to do the same thing with the 6. The 6 is missing a 2 and a 2. 2 times 2 is 4. So I'm going to multiply that one by 4 over 4. And the 8 is only missing a deuce. So I will multiply that one by 2 over 2. What? My bad, you're right. Look at me just fucking that up. Thank you for telling me now so that I don't keep going and go, why does this not work? All right, so I guess I kind of skipped a step. I didn't talk about how we multiply. Let's just cover multiplication real quick. When we multiply fractions, we multiply top separately from bottom. So the bottom is going to change. Unlike addition and subtraction. Students will often mix these up. They'll add denominators or they won't multiply denominators when they're multiplying. So I'm gonna write to the right of these what each of these turns into. This is 6 times 3 on top. And we already know the bottom's 24, so I'm gonna jump the gun. This one is 4 times 5 on top. And this one is 3 on top, 24 on bottom. 3 times 1. So this is where we're going to come down here. 6 times 3 is 18. Remember, now that we're adding these fractions, we can just add up the tops. 6 times 3 is 18. 4 times 5 is 20. And 3 times 1 is 3. This is going to add up to 41 on top over 24 on bottom. This is called an improper fraction. And if you're going to keep using it in whatever problem you're working on, this is just like a mid-step, don't change it. Improper fractions are a hell of a lot more useful to use and easier to use than switching to a mixed fraction or mixed number. But I thought I'd just go over mixed numbers while we're here. So this is useful when there's more work. Useful with more work. I didn't leave myself a lot of room to write that. So if you want to make a mixed number, like 1 2/3 is a mixed number. What we're going to do is we're going to divide the bottom into the top and see how many times it goes in. 24 goes into 41 one time. And we'll do some subtraction. I've got to borrow a 1 and I get 17. So if I want to write 41 over 24 as a mixed number, the number on top becomes the whole number, 1. The denominator is going to stay the same, and the remainder goes on top. So this is 41 over 24 is 1, and this is really 1 plus 17 over 24. But we tend to write it like this. What we've really done is we've taken 41 over 24, and it's still on the screen. Good. And we've broken it up into 2 fractions. We've broken it up into 24 plus 17 over 24. And then we've got 24 over 24 plus 17 over 24. And then the 24 over 24 turns into a 1. So I'll cross that out because that's misleading. That comes around to this step right here. That's technically what's going on. We skip all that when we're teaching shit like that. But it's helpful because you're going to be doing stuff with it that has more steps in it, and there's going to be variables in it. It's kind of helpful to know what's really going on. Was that fun? Was that everything you hoped for?
I might these coming down here. I have never done
The table?
that.
It's really helpful when there's multiple denominators. The other problem when, because a lot of, if I just had 3/4 and 5/6, a lot of instructors, or it's commonly taught, just multiply by the other denominator. Which works, it definitely works, but it almost always means they're gonna have to end up simplifying later on. Like almost always. You will find when we're doing greatest common factors, it will be the column that is completed. So in this table, the twos were all there, so the greatest common factor is 2, we'll do that later. Let me give you guys a practice one. Whether you use the table or not is entirely up to you. I think it's helpful, and I think you're gonna like it for other things later on. Again, I'm gonna continue to use it. I don't know, let's see, let's make some shit up. Let's go, let's do 1/6 plus 5/12. Oh, let's change some shit up. Let's throw in a -1/4. Let's put a minus sign in there. Just because I'm feeling devious. Let's have a fucking 3 base. Let's go big. In a while, I really like this thing. I was very pleased with myself when I figured it. I did this table for the least common multiple, and then later on I realized it works for greatest common factor too when you're doing factors. Like, oh my god, I'm brilliant. It's very good. So, some water. Making yourself order some. Hey. Library someone. I like the new one. That new library that they built.
Here.
Yeah, it's what I want.
Then I saw the car just going in. Go back to the
Comfy? Doing a practice problem right now. We'll go over it in a second. That's my great speed. She missed my table of explanations.
Sorry, I was chasing a dog on the street.
Did you finally hit it?
No. She said she was.
That was funny as hell.
That was fun.
She didn't say she was trying to catch it or catch it. She said she was chasing it. You run that fast that it flattened your hair?
And I was curled, it was super curled this morning, you know,
That's fucking fast. If you can run your hair straight,
in Converse, especially white ones, that one also white.
but to run your hair straight. That's fucking deep. That's like Flash. Seriously. It's like- I'll build the table with you, and hopefully get everybody on the same page. So what I'm gonna do is I'm gonna put my numbers that I got for the denominators here, put a line here, so I don't fuck it up. 6, 12, 4, and 5. And if I factor the 6, I got 2 times 3. 12 is 2 times 6, and 6 is 3 times 2, so I need another column for another 2. 4 is 2 times 2, and I have both columns there, so I'll do that. And 5 doesn't show up in any column, so it gets its own column, and it's a prime number. So your least common least common denominator should be 2 times 3 times 2 times 5. 6 times 10 is 60. You got 60, you got a good start.
I've done the first part of the problem before you had anything like that.
Hmm?
I had done the first part of the problem before you had to do this.
I had to make it more fun. I'm waving at the Zoom camera.
Find out here, we-
It's recording and presumably I teach till 7. But when I get out of class at 7, I'm gonna scan all my lecture notes, I'll upload them when I get home. And usually by the time I get home, Zoom is done doing everything, and I'll download them and put them on YouTube and upload them to our Canvas. All right, so what we're gonna do is we're gonna fill in the gaps and see what we need to multiply by. 6 is missing the 2 and the 5. 2 times 5 is 10, so I'm gonna multiply this by 10 over 10. The 12 is just missing the 5. So multiply that by 5 over 5. 4 is missing a lot, it's missing 3 and 5, which is 15. So we'll multiply that by 15 over 15. And 3/5 is missing 2 times 3 times 2, which is 12. So multiply that by 12. You notice all those denominators are 60. So I've got 10 times 1 plus 5 times 5 minus 1 times 15 plus 3 times 12. Here I didn't multiply anything out, I'm just condensing them all into one fraction. So now I'll start cleaning up. 10 times 1 is 10. 5 times 5 is 25. 1 times 15 is 15, that one's a minus. And 3 times 12 is 36. Bottom is all 60. If I go left to right. 10 plus 25 is 35. Minus 15 is 20. Plus 36 is 56 over 60. Okay, now. Did everyone get 56 that finished it? Get 56 over 60? Okay, now we want to reduce it. So to reduce it, guess what? Since we did our table, we already know what the bottom looks like. We know it is 2 times 3 times 2 times 5. I don't need to try to refactor 60. I know what it is. I already had it. That's convenient. 56 is what? 8 times 7? Or 7 times 8? And 8 is 2 times 2 times 2. 7 times 8 was where I started, and I went from there. And I see a couple deuces cancel. Remember, they don't go away, they're turned into ones. On top, I'm left with 7 times 2. On bottom, I'm left with 3 times 15, or 5. So I get 14 over 15. That's another perk of the table. You've already got the denominator factor. Which isn't too bad when it's with 60, but when it's like 1,280, you're like, fuck, this is gonna take a while. And you probably would do this most of this with a calculator, but the calculator isn't gonna do the algebra shit for you. So this very idea works when we have variables in it. As you'll see when we get to that, not today, but it'll be, I think Thursday. If it's not Thursday, it's next week. It's soon. We're doing factoring soon. All right, so that was multiplication of fractions, division of fractions. Let's say I want to divide 3/5 divided by 1/4. So when you're dividing fractions, instead of dividing by a fraction, multiply by its reciprocal. And reciprocal just means flip it over. I think the book might use the word invert. What this means here is I'm going to leave the 3/5 the same. The division sign is going to turn into multiplication. And I am going to flip that sumbitch over. So now it's 3 times 4 on top, 5 times 1 on bottom, which is 12 over 5. And if you go through the process of getting a mixed number, that would be 2 2/5. Page 3. This kicks up a little bit when we add in mixed numbers. So let's see mixed numbers. And then we'll have a break until the other class starts. Make sure everyone's got a chance to write this.
On the quiz, we're definitely gonna have divisions, right? This is what we are.
Yeah, there's stuff in there on
Does
division.
it matter how we want to like if we just leave it as probably five, or we want to put everything?
Unless I'm very specific and say, write it as a mixed number or reduced or something like that. Just getting it in the 12th is almost is correct. If it's on the test and I specify and we don't do it, not reducing is like 1 point, or changing is like, 1 point out of like 10, not a big loss. I tend to make tests and stuff. I hate using 100 because then it makes it so I have to use like, if I want 20 problems on a test, I don't know that I do. But if I want 20 problems on a test, I have to make each one worth 5, which means 1 point out of 5 can be a hit. So I tend to make tests worth more, but it's still the same percentage of your grade. But people will see like a 200-point test, 300-point test, but then I can make each problem worth like 20 or 30. And and then 1 point out of 20 is not a big hit.
And normally how long
We'll have the full 2 hours when we do a test.
we don't refresh it or do it?
I don't know at this time. I'll let you know. You'll have a practice before we do it.
Okay, I was wondering.
Not only will we have a practice, I'll show you that. I'll give you a blank one to do and we'll walk over it in class. So you'll be able to look at the answers. You'll take the practice test with you. You can take it home, practice it on your own, and then look at the answers afterwards. All right, dividing by mixed numbers. You will find that I am a merciful God. I'm waiting for someone really religious to say, "You're not God." No one's ever done it yet. I'm waiting for it. All right, so let's say we're going to take 6 1/4, and we're going to divide it by 3 2/5. All right, so the first thing, convert to improper fractions. By finding a common denominator or using the denominator, not the denominator. So what I mean by that is, remember, this is 6 plus 1/4, and this is 3 plus 2/5. And what I'm going to do is, to get the top all into one number, I'm going to multiply the 6 by 4/4, and I'm going to multiply the 3 by 5/5. Six is really like 6/1, and 3 is really like 3/1. So we can multiply those together. And on top, I've got 24/4, 4 times 6, and then plus 1/4. On bottom, I have 5 times 3 is 15 over 5 times 1 is 5, plus 2/5. And when we add those together, I have 25/4 on top and 17/5 on bottom. Then do the reciprocal magic. So I'll rewrite this down here and where I have a little bit more room. I'm dividing 25/4 by 17/5. This is what I'm dividing by, the 17/5. So what I'm gonna do is I'm gonna flip that over and I'm gonna multiply it by 5/17. And I'm gonna do this on top and bottom. This is the easier way to do it when you have it in this giant complex fraction. This is when you have got fractions within fractions. This is called a complex fraction. And now shit in common will cancel out, like notice the 17 here and the 17 here, those cancel. And the 5 here and the 5 here, those cancel. They cancel because they're multiplied together. And anytime the numerators they're multiplied together, the numerators get multiplied together, the bottoms get multiplied together, we cancel. This whole bottom right here turns into a 1. And which means it's gonna go away. So all we've got left is what's on top. What I have left on top, let's see. Rather than multiplying them together first, what I'm gonna do is factor them a little bit. 25 is 5 times 5. 4 is 2 times 2. And then I've got 5, which is prime, and 17, which is prime. The reason why I did it is because I wanted to make sure nothing canceled. It sucks if you multiply the big number and then you're trying to undo it and find your factors again. Here I can see nothing cancels though. So nothing cancels, so I can just do the math. 25 times 5 is 125. 4 times 17, what is that real quick? 17 times 4, 28, 68. 68. I've got 125 over 68. That's technically the correct answer. If we want to simplify it, we're going to divide 68 into 125. It only goes in once. I got 57 left. So this will become the 1 on top. And then the 57 is the top and 68 is the bottom. So that's the equivalent in mixed numbers. Ideally, you want to put it back in the form you started with. So we started with mixed numbers. We should probably end with mixed numbers. That's a general good rule of thumb to answer your question a little bit better, but and now we got a break for like 10 minutes, and we're gonna have a guest speaker start off our next